Hello and welcome to this YouTube channel. Today's video we are going to be dealing with Python operators. What are Python operators? Python operators are special symbols which perform operations on variables and value. Now, if you remember in the last video, we treated Python variables, and if you can remember very well, we have numeric variables, we have alphabetic variables. So today we are going to be looking at Python operators. How do we get to manipulate these variables? And with the help of these Python operators, that's how we get to do that. Python operators, as you said earlier, they are special symbols. We use them in manipulating Python variables. Now, we have 7 different Python operators. We have the arithmetic Python operator, we have the assignment operator, we have the comparison operator, we have the logic operator, we have the identity operator, we have the membership operator, and we have the bitwise operator. Now these operators, we are going to be dealing with them one after the other. But before we do that, let's quickly move into Jupyter. This is our Jupyter interface, and we are going to be creating a new notebook, and this notebook we are going to be naming it Python operators. That's what we're going to be naming this notebook. If you don't have Jupyter on your system, you can use your PyCharm IDE or you can use your Visual Studio Code. But if you want to have Jupyter on your system, I have a video and I'm going to be leaving the link to that video in the description of this video. So we're going to name this Python notebook Python operators. Now, quickly we're going to start with arithmetic operator. What's the arithmetic operator? The arithmetic operator is used to perform mathematical operations on numeric variables. Now, many of us remember when we were in school, when we did maths, we did things like addition, subtraction, multiplication, division, and we did things like raised to the power of, that is square, square root, and so on. Now, these arithmetic operators, these symbols, are what we use in achieving the same with Python. So we're going to start with the addition operator, the addition. And as we know, addition is simply adding two numbers together. If we have two variables, let's declare x is equals to 8, and we declare y is equals to 9. Now, if the arithmetic operator here, which is addition, we can simply say x plus y will give us what? 17. It's just adding two numbers together. So this is the what? The addition arithmetic operator. So let me quickly write it here. Addition arithmetic operator. Okay. Now let's look at the subtraction. It's another arithmetic operator. And we're still going to be using our previous variables that we used, which is x and y. So if I should say x minus y, this should be giving us minus 1. So we are seeing that 8 minus 9 is going to give us minus 1, even in our normal math. So Python is also intelligent in its own way. And we'll say y minus 8 or y minus x, this will give us 1. Please, we should understand that these y and x, just like I said in the Python variable videos, they are location reference points. That is memory location reference point. This y you see here now, this y is simply 9 and this x is simply 8. So it is still the same thing as me saying 8 or say 9 minus 8. So it's just the same thing. They are variable names which point to a memory location. If you really want to know more about variables in Python, you can go to our previous videos on Python variables. It's very explicit and you will learn a lot from it. So quickly, let us go to the multiplication arithmetic operator. Multiplication is not the normal x that we know. In Python, multiplication is represented as the asterisk sign. So x multiplied by y, and that will be giving us 72. That is the for multiplication in Python. Quickly, we're also going to be looking at division. Division. The division in Python is the /, which is x divided by y. This is going to give us 0.8, and y divided by 8. This is also going to be giving us 1.125. If you have your calculators there, you can always check for the authenticity of this code, but I know that Python is correct. Quickly, we're going to be looking at modulus. Now, what is modulus? Modulus is an operation in Python that when you divide two numbers, it will give you the remainder of those two numbers. That means if I should have 5 modulus 2, 5 divided by 2 on a normal mathematical ground should give us 2 remainder 1. So, but this function, this operator modulus, what it does is it gives us the remainder. That means when we have 5 divided by 2, it gives us 1, which is the remainder of our division. The same thing, we can say x modulus y. What is it going to give us? 8. Now, 8 divided by 9 is not up to 9, so the remainder is going to be 0 remainder 8. So some of us that were good in maths, this is not supposed to be a problem for us. If you are good in maths, you can quickly visit your elementary maths, but I know we are. Okay, now let's look at flat division. There is also an operator in Python called flat division. Floor division, please. What does floor division do? Just like your normal division gives you with the what it has divided and the remainder, what floor division does is that it rounds everything up. It just gives you the whole number. It's not that you round everything up, please. It just gives you the whole number. That means if I should say 6, and flat division is represented with double forward stroke. So 6 divided by 5. This should give me 1. It will give me 1. It gives me only the whole number. It does not give me the remainder. Just like the modulus gives you the remainder, the floor division gives you the whole number, what it divided. That means if I should say 78 divided by 4, this should give me 19. That means 4 went into 78 19 times. For those of us who know maths, you understand what I meant. So quickly, these are for the arithmetic operators. We have the addition, subtraction, multiplication, division, modulus, and floor division. Okay, quickly let's look at the assignment operators. The assignment operators are used to assign values to variables. Now, assignment operators there are different types of assignment operators. We have the assignment operator, which is the equal to. We have the addition operator. We have the subtraction operator, the multiplication operator, the division operator, the remainder operator. We have the exponent operator, and we have the floor division operator. So quickly, we're going to be looking at each of these operators one after the other. We're going to start with the assignment operator. Now, if I have a variable x and I want to assign it a value 2, this is the symbol I use in assigning 2 to this variable name. So 2, which is my data, is assigned to x, which is a variable name, using this symbol equal to. That means if I should print out x, I'll have 2 in that particular memory location. That is for the assignment operator. Now we have the addition assignment operator. The addition assignment operator. Let me represent it as AO. Now, what does this do? It's just a shortcut. Normally, if I was supposed to type x is equals to x plus 1. If I was supposed to type this with an assignment operator, I could easily just do it this way. It's the same code. So let's look at the both of them individually. Let's see. Assuming I have x is equals to 5, and then I have this. Let me clear this. This is supposed to give us x is equals to 5. So the new value of x should be 5 plus 1. So if I should have this, this should give us 6. Let me print out what x is, 6. Now, what if I repeat this code again, whereby I say x is equals to 5? Then I now use the addition assignment operator, whereby I say x plus equal to 1. And I print out the value of x, it's still going to give me 6. So instead of going through the long process of saying x plus 1, you can easily just push your code up by using the assignment addition assignment operator. The same thing with subtraction assignment operator. If I have x is equals to, okay, let me just use x is equals to 6, because currently x is equals to 6. So if I want to subtract 1 from x now, I'll simply just say x minus equal to 1. And if I should print x, it should give me 5. If I should do the same thing again, x minus equal to 1, and I should print x, it will give me 4. So it's subtracting by 1. If I want to subtract by 2, it's also the same thing. X minus equal to 2 should give me 2. 2. So this is it for subtraction assignment operator. We also have the multiplication assignment operator. All these things just works with the same principle, whereby if I want to have, currently x is equals to 2, so if I want to do 2 times 2, I can simply say x times equal to 2, and if I should print out x, this should give me 4. So it's simply saying 2 times 2, and if I want to multiply this 4 by probably, let me say 5, I will simply say x times equal to, sorry, not separately, x times equals to 5. And if I should print out x, this should give me 20. So that's it for the multiplication assignment operator. Then the division assignment operator does virtually the same thing, whereby if I say x divided by equal to, if I want to divide it by 4, for instance, and I print out x, this should give me 5.0. Okay, now let's quickly look at the remainder assignment operator, exponential assignment operator, and floor division assignment operator. Now, these operators work similarly like the ones we've seen. For example, if I have x is equals to, let me say 9, and I have that y is equals to, let's say 3, or no, let's say 2. Yes. And now I want to use the remainder assignment operator. Let me write it. Remainder on, doesn't sound good, modulus assignment operator, AO. I can simply just say x modulus equals to y. And if I should do this and I print x now, x will be the remainder of 9 divided by 2, which is 1. I hope we get this. If you have any question, please feel free to ask in the comment section, or there is a link to a WhatsApp group that you can join, where I am always available to answer your questions. Please. I believe this is clear with modulus assignment operator. Then we have the exponential assignment operator, which virtually does the same thing. If I have variable x is equals to 7, and I have variable y is equals to 2, what I can simply do here now is to say x double multiplication equal to y. And if I should print x, this will give me 49, which is the same thing as saying 7 raised to the power of 2. Double multiplication is what we use for saying raised to power of. Sorry, I did not treat it earlier while I was treating arithmetic operators, but double multiplication is what we use for raised to the power of. That means if I want to say 5 raised to the power of 2, 5 raised to the power of 2, which is 25. So this is just a way of saying 5 raised to the power 2. I'm sorry I didn't treat it in the arithmetic operation. I probably skipped it. So back to where we were about the exponential assignment operators. I hope this example is clear enough for us. And let's quickly move into the floor division assignment operator. So if we look at this, it's just going to be doing the same thing whereby we have our x and y. You must understand currently that our x is equals to 49. I want us to be using that same variable, and we're going to be using y is equals to 2. So if I should remember what floor division does, it gives us the whole number. It doesn't give us the remainder. So when we divide two numbers, the floor division simply gives us the whole number, leaving out the remainder. So if I should have x floor division equals to y, this should give us the whole number. So simply what we're going to be saying is 49 divided by 2. X, which is 49, and y, which is equals to 2. This should be giving us remainder of 1. So if I should print x out, 24 is the answer, because it's giving us the whole number, not the remainder. I hope this is clear, and I hope we understand assignment operators. If you have any questions, please feel free to go to the comment section and ask your question, or you go to the link to the WhatsApp group where I'll be answering all questions at any time, and just join the group. Quickly, let's move into the next operator, which is the comparison operator. Just like the name sounds, comparison operators. Comparison operators are used to compare two variables or more than two variables, and we can also use them to compare expressions. When we say expressions, we're talking about equations. In the mathematical term, we say equation. When we're talking about it in Python, we say they are expressions. And when these two expressions or variables are compared, it returns a Boolean variable. That means it returns a Boolean result, which is either true or false. So now we are going to be looking at what these operators are and how we use them for both variables and for both expressions. Now we have the first one, which is the equal to. So if I should have x is equals to 7 and y is equals to, that means what I mean here is x assigning 7 to x and y assigning, let me assume, 9 to it. If I want to use the equal to as a comparison operator, I'll simply say x is equals to y. Now, if I should print this, the Python will tell me if the expression I made is true or false. So x obviously is not equals to y because x is 7 and y is 9. So this is false. So, but what if I have x assign 8 to it and also y assign 8 to it? We have x is equals to y. You see, it gives us true. Now, for some of us now, some of this would not be making sense. But as we advance in this course, you will be needing this because we are going to be using a lot of it, especially these comparison operators, because we're going to be making decisions. Because basically, writing program is a question of making decisions in your program. So that is just it. So these comparison operators are basically what help us in making decisions. So another comparison operator we have here is the greater than operator. Now, what's the greater than operator like? This is the greater than operator. Some of us who did not like maths in school, we could be not liking this now. Greater than operator, which is this. And how do we use this? If we say x is greater than y, is it true or false? It's false because they are equal. They're not greater than each other. But if I say x is equals to 7 and y is equals to 9. If I should say is x greater than y, of course it's false. But if I should say is y greater than x, this is true. Please, I really say that you should pay serious attention to these classes because we are going to be needing this in future. Remember, we are laying the foundation for Python programming language. So these are very important parts of this course. Don't get bored. Instead, get encouraged to want to learn more, have questions, explore it. The next operator we're going to be looking at is the less than, which is like this. Just like the greater than, it virtually does the same thing. Is x less than y? I'm doing that indentation error again. Please, we should make sure that we do not have spaces in front of our program only when necessary, because Python are very sensitive to it. So this is true. X is less than y. X is 7 and y is 9. So obviously 7 is less than 9. So let's quickly look at the next operator, which is the greater than or equals to operator. The greater than or equal to operator. So the greater than or equal to, and this is how it is represented, something like this. So if I should ask this question to the program saying is x greater than or equals to, please no space, is x greater than or equals to y, is false because x is not greater than y, it is not equal to y. So but if I should have x is equals to 8 and y is equals to 8, probably it will tell us true. So let's try it. X is equals to 8, y is equals to 8, then is x greater than or equals to y? Okay, sorry please. So let's try this. Is x, so it's true because both of them are equal. Now let's look at the next one, which is the less than or equal to operator. Is like this. This is just it. So if I should ask the question, if x is equals to 7 and y is equals to 9, if I should ask is x less than or equals to 9 or is equals to y, we have true. So these are very simple operators that we could always toil around with. The comparison operators are one of the very simple operators. Now, quickly, next operator we're going to be looking at is the logic operator. What's the logic operator? These operators are used for decision making. Some of us who did computer science very well in school will know some of these operators, and basically there are three in Python. We have the AND, the OR, and the NOT. Quickly, let us begin to look at the AND. The AND operators, basically what this logic operator does is almost the same thing with the comparison operator. When it accesses two variables, and these variables are either true or false. So if both variables it is comparing is true, the AND, that is only when the AND will give true. If both are false, it will give false. If one of them is false, it will give false. We're going to be looking at it now. Now, for now, we're going to have true. Okay, let's do it this way. X is true. Y is false. If I should have X and Y, remember I told you X is true, Y is false. So X and Y, true and false, will give me false. So if I should have true and true, which is X and X, this will give me true. In fact, let me do it this way. If I have true and false, this will give false. If we have true and true, this will give true. If we have false and true, this will still give false. What this simply means is if any expression that we have by this side is true and the expression we have by this side is false, this whole operation, this whole expression will become false. That means if I should say, if I should have a conditional statement, we're going to be looking at that in the future. And under that conditional statement, I would ask that I would tell my program if what this person scores is above 80 in, that's what the person scored in maths is above 80, and what the person scored in English is above 80. Assuming that's the condition I gave. If what you scored in maths is above 80 and what you scored in English is above 80, that is when that person should pass. And now the first person comes into your office. Yes, that person scored above 80 in maths, but did not score above 80 in English. Automatically, that person did not pass because the person needs to score 80 above 80 in both maths and English. I think this is a better example. The same thing is happening here. This person scored above 80 in maths and scored above 80 in English. That is why the person is passed. That is true. And this person did not score above 80 in maths and scored above 80 in English. Still is false because you need the both of them to go. That's just basic about and. But when we have another operator which is or we have how or works is you either have this or you have this. If you have the both, it's fine. But you either have this or this. So that means in or, if you have the both, it's fine. So if we have true or true, true, that means if you score this or you score this, you are good to go. If you have true or false, you are still good to go. True. If you have false or true, sorry, please forgive me. This should be capital letter. Still true. Are you with me? The only condition where false get to be false is if you have false or false. That's when you get it to get angry, it tells you false. Hope this is understand. I explained it in the best way I can. But if you still have questions, feel free to ask me in the comment section or you join our WhatsApp group. I'm going to be answering questions there. Then for the not is just simply the opposite. So if I say not true, is false. And if I say not false, it's true. So we call it an inversion operator. Use it to turn it around the opposite of what we have. So I hope we are very clear with the logic operators. Now we are going to be looking at the identity operators. Identity operators. Please, if this video is getting too long for you, you can pause it, rest, take a drink, take a shower, take a nap, come back, and continue. So now we're going to be looking at the identity operators. These are operators, which is the is and is not. They are special operators. We call them special operators in Python. So is or is not. So these are just the two operators they have. Let me type it here. Is and is not. So what does this do? If I have two variables, it's just still almost like comparison. X is equals to 8 and y is equals to 9. So if I say x is y, this is obviously false. Oh god, what's me and this? Okay, sorry please. This is it. So this is obviously false. 8 is not 9. So basically, these identity operators, it returns also Boolean variables. It returns Boolean results. So is, this is what you get. If I say X is not Y, reversely I get true. So this is important. Assuming if you are working with, let me still say, conditional expressions, conditional statements, and you have a result from maybe from your input or from what the data the person has put into your system, and or probably you are trying to do an exam site whereby you log into the site and the person answers the questions and the program is programmed to take the person's score and display to the person. So basically this is how you be doing it. If the person should bring in his option, which is X, you check if your answer, which is Y, is the same with it. So you ask the program, this answer this person bring, is it Y? That means, is it the same thing with Y? If yes, print true. If false, this is what you should do. So that's why I said these are fundamentals that we are learning. We are going to soon be using them. It will not make sense now, but it's important that we follow. It might not make sense now, but it's important that we follow because we are going to be looking at it soon, soonest. So now, if these are just for identity operations, you are identifying if both of them are the same. So is X is Y, is it the same? If not, false. If yes, true. So that's just it. It's not. X is not Y. If true, print true. If false, print false. So that's just it for identity operators. If you have questions, you know where to go. Quickly, we're also going to be looking at the next one, the membership operator. Membership operator, just like the name sounds, membership. The variable you are going to be looking at, is he a member of this? Are we together? So it's also a special operator and has just two variables, which is in. Please let me put this in comments, which is in and not in. Not in. So these are the two it has. So assuming if I have a string, let me assume S is equals to hello world, hello world. And now I want to ask a question. Remember, this membership operator 2 is returning a Boolean result, which is either true or false. So I can simply ask H in S false. Now this is false because there is no small letter H in this. Or if I say capital letter H in S, this is true. So explore with this. I don't want this video to be too long with examples, so you already know what this concept is actually about. So I want you to explore with it and find different ways you can manipulate this variable. Okay, let me just give one more example. Assuming I have y, and y is a list of numbers. Let me say 1, 2, 3, 4, 5. This is y, and I simply ask the question 1 in y. Obviously 1 is in this is in above numbers. If I say 9 in y, this will give me false. Then if I say 9 not in y, this should give me true. So I believe we understand the concept. If there are any questions, please do well to go into the comment section and ask your questions. Now, this part we are going into is one very big part, which is the bitwise operator. So if you are exhausted at this point, I would advise you go, you take a chill, and you come back. We're going to be looking at this point, we're going to be looking at the last one, which is the bitwise operator. Bitwise operator. I would like to take my time to explain this. So if you are tired, please go and take a chill, then come back. Now, what are bitwise operators? Bitwise operators are used to perform bitwise calculation on integers. the integers are first converted to binary. Then operations are carried out one by one, that is bit by bit, on each of the binary value of that particular integer. Let me explain. Let me quickly go to Paint. If I have a variable 2, for example, or no, let me don't use 2. 2 is too easy. Assuming I have a variable 10, and I'm supposed to take the maybe bitwise and bitwise or, because these are types of bitwise operators. I'm going to get to that, but let's just, so I have to first of all take the binary form of this, which is, I believe some of us who are good in maths, we know what I'm doing. If I divide this by 2, I will have 5 remainder 0. If I divide this by 2 again, I will have 2 remainder 1. And if I divide this by 2, I will have, sorry, my dear, I will have 1 remainder 0. And finally, divided by 2, I will have 0 remainder 1. Now, automatically, I'm going to be taking it from the up, which I have 1, 0, 1, 0. So this is my binary form. This is the binary form base 2 of 10. Now, if a bitwise operation should be carried out on this, each of these bytes, these are called bytes, will be worked on compared with the other one. Assuming I have 10 bitwise 12. So 12 will also be converted to a binary form, and the last bit of 10 will be compared with the last bit of 12, and so on and so forth. Now, quickly, let me say something. Our systems work in 32 bits. Our systems work in 32 bits. So, how this binary is represented in our system is 0, 0, 0, 0, 1, 0, 1, 0. This is how it is represented in a 32-bit machine. So this is just for clarity's sake. I believe this is clear. We understand this. Now let's go back to our Jupyter. So now, bitwise operators, just like I showed you now, operations are carried out on each of the bits. Each of the bits, that's what operations are carried out on. Now, let us now see the types of bitwise operators we have. We have the AND, we have the OR, we have the XOR, and we have the NOT. I would like us to pay serious attention. I said we have the AND, we have the OR, we have the XOR, we have the bitwise right shift and bitwise left shift, and we have the NOT. So this is the progression I'm going to be taking it in. I'm going to first of all take the bitwise AND. Next, I'll take the bitwise OR. I'll take the bitwise right shift, bitwise left shift, and the last one I'm going to be taking is the bitwise OR. I mean bitwise NOT, please. Now let's take the bitwise and please, these are supposed to be in comments. Let's take this one. Now, when we are taking the bitwise and the bitwise and is represented with the ampersand symbol, that's the representation. That means if I have 10 and 12, let me use that example, I'm going to have 8 in decimal in base 10. Now, let me show you how did this come about. Okay. Now, assuming we have 10, this is in decimal form. The base The binary form of this is, as we said, in 32-bit is 0, 0, 0, 0, 1, 0, 1, 0. Now, when working with AND, this might not be very important. So, for 12, the binary form for 12 is, let's quickly check it here. We have 6, remainder, 0, 2, 3, remainder, 0. We have 2, which is 1, remainder, 1. And we have 2, which is 0, remainder, 1. So this is simply 1, 1, 0, 0. Just like I told you, this one is not important. And what we have here is the ampersand, which is the AND. Remember, just like the normal AND, when both of them is false, that is 0, 0, our answer should be 0. That means 0, 0, our answer should be 0. When one of them is true and the other one is false, since it's AND, it will be what? It will be false. When one of them is false and the other one is true, it is still what? False. And when both of them is true and true, then we have true. Now, if we should take, this is base 2. Those of us who are good in maths, if you remember, if you want to convert this back to decimal, we have 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. And then this is the only one that matters, because by the time we multiply 1 times 2 raised to power 3, it will give us an answer. But these other ones will give us 0. So we have 1 times 2 raised to power 3, and this will be equals to what? 1 times 8. And 1 times 8 will simply give us what? 8. So that is how our machine arrived at the answer 8. So I hope this is clear. I want us to explore more with it, and then I'll be looking at the bitwise OR now. The bitwise OR is represented with the single strike. So by the time I say 10 or 12, our answer should be 14. Now let's see how did our machine arrive at this answer. We say select. All right. We already know that our 10 is what? 1, 0, 1, 0. And our 12 is what? 1, 1, 0, 1. And we are looking at our OR. Our OR is represented with a single strike like this. So our answer will be 0 or 0. That is false or false. Is what? Is false. True or false. Remember, once one is true, it's true. True. False or true. You can either pass, you failed maths, but you passed English. So anyone will go. You passed maths and you pass English, you are still good to go. So this is what we get. Now, remember, as we said, this is in base 2, and when converting, we start with 0, 1, 2, and 3. So automatically, this is 8 plus 4 plus 2. And this should be giving us equals to 14 in decimal form. So I hope this is very clear. That was how our machine arrived at 14. Now let's look at the XOR. The XOR, bitwise XOR, is represented with this. So therefore, if I say 10 XOR 12, this will give us 6. Now, how did our machine arrive at this? Let's see. Quickly, let me clear this. Now, remember our 10. We have 10. 10 is equals to 1, 0, 1, 0. and 12 is equals to 1100. What our XOR does is 1. If 1 is true, it's true. If 1 is true and the other one is false, then it's true. Then if both of them are true, it's false. If both of them are false, it's true. That means you are allowed to either pass maths or pass English. If you pass the both, you have failed. If you fail the both, you have failed. But if you pass maths and you failed English, you enter the kingdom. But if you failed English and you pass maths, you still enter the kingdom. But if you pass maths and pass English, you won't enter the kingdom. If you failed maths and failed English, you are not entering the kingdom. So this person failed maths and this person also failed English. So he's not entering, which is 0. He passed maths and failed English. He's entering. He failed English and passed maths. He's entering. He passed maths and passed English. I too know. He had not entered the kingdom. Are we together? I hope this is understandable enough. Forgive my joke, but that's the best way I feel I could explain it. So remember, this is base 2. Our system, how did it arrive at 6? So let's quickly see. This is 0, 1, 2, and 3. This one is automatically 0. So we have 4 plus 2, which will give us equals to 6. Please, if you don't know how I'm converting this binary to decimal, you can always go back, watch some tutorials on this conversion from binary to decimals. It's very easy, but I believe this small example should clear it. Or quickly, let me give a small example. This is simply 0 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 1 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. So automatically this is cancelled out and this is cancelled out because they are 0. Now 1 times 2 raised to the power of 2 is 4. So we have 1 times this is 4 and 1 times 2 raised to the power of 1 is 2. So that's how we arrive at 6. I hope this is understandable enough. Now quickly, that is for XOR. Now I want us to go to the bitwise right shift, bitwise left shift. So let's start with bitwise right shift. Bitwise right shift is represented with this double greater than sign. Double greater than sign. So let's look at, so if I should have 12, for example, and right shift it twice. Remember, you can right shift it once, twice, 3 times, 4 times, depending on the amount you want. So here I want to right shift it twice. I'll get 3. How did we arrive at this? Let me show you. We go to paint. We go to paint, select. Let's clear all of this. Now we already know that, excuse me, we already know that 12 is equals to 1100. Now to right shift, we are going to be moving this way, isn't it? Now the system has assumed that this is written as 1100 point. That is what the system sees, point. Now this, after this point, we have 0, 0, 0, 0, infinity. So now when we say right shift, what we are simply doing is that we will move, remember it's right shift twice. So we will move these 2 twice to the left over this point sign. That means what we're going to have is 1.00, because we move these 2 now to the right. That's simply what we have. Now remember, this is base 2. Converting this now, if we convert this now to binary, and this binary back to decimal, we'll have 0 and 1. So automatically this is 2 plus 1, which is equals to 3. That is how our system got about 3 in this place. So what about left bitwise left shift? Bitwise left shift, we have 12, sorry. Left shift is represented like this, less than twice. So we want to shift it twice too. What do we get here? We got 48. Now, how did this come about? Let's see. Let me first of all clear here. It is just it's simply the opposite of the right shift. So if I have 12 is equals to 1100, remember I told you 0.000 till infinity. Now if I'm left shifting, I'm moving towards this angle. That means I'm going to move 2 zeros over to this side. Remember that these zeros are up to infinity. So that means if I have something like this, I'll have to move them over to this side. So we have 11000.00 till infinity. So if I should convert this, I have 0, 1, 2, 3, 4, and 5. Now 2 raised to the power 5 should give us 32 plus 2 raised to the power 4 should be giving us 16. This plus this should be giving us 58. Okay. Yes, sorry, please, this is 48, not 58. Oh my god. Please forgive me. This is 48. So this will give us 48. I hope this is understandable enough. And I hope these examples I gave is understandable enough. Quickly, let us move into the bitwise knot. Now, the bitwise knot looks like the most easiest, but in fact, it's the easiest, but it depends on your understanding. I've researched on so many tutorials that gave their own explanation on how bitwise knot works, but I'm also going to be giving my own explanation here today, and I hope mine is better. So bitwise knot is represented with this, and now when we say knot 10, this will give us minus 11. Now, how did we arrive at this? Bitwise knot gets to change even the sign of your number, even the sign of your integer value. Now, assuming I'm working with, let me work with the 12 we've been working with, 12, and 12 is represented as 1100. Now, remember I told you that our 32-bit machine sees this as 0, 0, 0, 0, 1, 1, 0, and 0. How do we get minus 11 from our not 12? What not does is it changes everything. Remember, just like as I told you before, if it was 0, it becomes 1. If it was 0, it becomes 1, 1, 1. This one should become 0, 0, 1, 1. Now, because it's not, we minus 1. This is how I arrived at my own solution. I'm not saying this is the ideal way to do it. This is how I arrived at it. So 1 minus 1 is 0. Then we bring down the others. Now, after we've done this, we now convert it back. We take the complement of this again by saying this will give us 0, 0, 0, 0, 1, 1, 0, 1. Now, if I should take the base 10 of this is 0, 1, 2, and this is 3. So this is 8 plus 4 plus, this is 0 plus 1. 8 plus 4 will give us 12, and this is 13. Now we simply now say minus 13 because the not gets to invert everything. Sorry, please, I did not 10 here. So not 12 will simply give us minus 13. This is the way I arrived at mine. If I decide to do not 10, it will still give the same result. Remember, please, disclaimer, I said this is not the ideal way to do it, but this is how I arrived at my answers. If I should have 10, the binary value of 10 is 1010, and in 32-bit it is represented as 00001010. If I take the complement of this, I have 11110101. If I should minus 1, I have 11110101. And if I should take the complement of this again, I have 0000101. Sorry, please, this is 0 1. So if I should now convert this now to base 10, this is 0, this is 1, this is 2, and this is what? 3. So I have 8 plus 0 plus 2 plus 1, and this will be giving us equals to 11. Now, because we're looking at not, it also inverts the positive sign to negative. That's how we arrive at 11. This is how I solved it. I hope this is understandable enough. If you have any questions, you know what to do and you know where to go. So quickly, finally, before we end this video, I would like to talk about how operators are like their scale of preference. Now, the parenthesis always has the highest priority, the highest preference, followed by the multiplications and the divisions. Then we have the addition, and then we have, before we begin to get other operators, that is their level of priorities. That's how they are prioritized. And then secondly, if you have addition and subtraction in an expression, if you have addition and subtraction in an expression like this, 4 plus 6 minus 1, because they have the same level of preference, it always starts by from the left to the right. That means it will first do 4 plus 6 minus 1 before it gives you the answer. That means this should be giving us 9. That means it did 4 plus 6, which is what? 10, then minus 1, which is 9. I believe this is understandable enough. If you have an expression like this, 45 plus 6 times 4 or times 5 minus 1 divided by 4 minus let me say 1. Now this will be the first to be attended to. These two will be the first to be attended to. Then the multiplication from the left. That means our system, let me quickly get the answer of this. Okay, this is what we'll get. That means what our system simply did. It first did 45 plus 6. We got 51. Then it did 4 minus 1. We got 3. It kept them. Then our equation turns to something like this. 51 times 5 minus 1 divided by 3. This was what the equation turns to. Now, because multiplication and division are in this equation and they have same preference, it will start from the left, thereby saying 51. It will say 51 times 5, whereby we get our answer 245. Then it says 1 divided by 3. It gets the answer. Then our equation turns to something like this: 255 minus 0.33333 till whenever it stops. Then it now does the final calculation. This is how it arrives at its answers. I hope this video you learned from it, and please subscribe, like the video, comment from where you are watching from, and I'll see you in the next video. Take care.